tutorial, I'll be explaining how to create this orbiting effect, using some simple parametric equations. For this lab, you'll need 2 models, 1 scene, and 3 scripts. The scene consists of 2 game objects. The camera, which I have positioned at 0, 0, 0, with an orientation of 0, 0, 0, and using the default field of view with perspective mode. You can use orthographic if you want. The camera has 1 scripted component attached to it, as does the core. The 3 scripts I'm using are startup, orbit, and spawn orbiters. First, look at startup, which is attached to the camera. In this case, all startup does is in its awake function, it calls the CraftStudio screen function setSize, and sets the resolution to 400 by 600. I only did that just because I felt the square window felt a little bit more appropriate for the project. Moving over to the spawn orbiters script, I have nothing in the awake function, but in the update function, I have the condition if input was button just pressed fire, and everything else is encapsulated within that conditional. The fire button is already included in your project to be left mouse button by default, unless you deleted it. The way spawn orbiters works is it does 2 steps. The first step is to declare all of the variables that it's going to need. It grabs the orbiting script, as well as the orbiter model, which is the blue square. But I'm also setting a variable equal to the CraftStudio function createGameObject, which creates a game object called orbiter and parents it to the self game object. The createGameObject function also returns a game object value in the same way that findGameObject does. So the createGameObject function saves us time. The next 3 lines of code apply to the game object we created, which the variable we're using to refer to it is called orbiter. First, it creates a script component and attaches the orbit script to it, which is a variable we defined earlier. The orbit script has some behaviors that we can assign values to within this. The next thing it does is it creates a model renderer component on the orbiter. Then it refers to that model renderer and tells it to set the model to the model we grabbed earlier. So in summary, the first 3 lines of code grab the things that we need. It grabs the model, it grabs the script, and then it creates a game object. The next 3 lines of code assign that script to that game object, create a model renderer component, and assign that model we got earlier through that model renderer component. All of these things are things that we can do from CraftStudio in the scene editor, but we do it all dynamically. So let's have a look at the orbit script to see what's really going on. At the top we have the behaviors: angle, spin rate, and radius. The angle is the starting angle of the object. I found out that with this implementation, it defaults to being in radians. Spin rate is the amount that the angle changes each loop. Radius is the distance from the core. The first thing we do in the update function is we set angle to itself plus spin rate. You could do this at the beginning or at the end of your update. In this case, I decided to do it at the beginning. The next 2 lines of code declare 2 local variables that are simply called x and y. The values they are assigned is based on this parametric equation. If you don't understand why this works, don't worry about it. The 3rd line creates a vector that we are simply calling temp vector, which holds the x and y coordinates of x and y that we defined earlier, and leaving the z at 0. The final line sets the local position, which is its position based off of where its parent is, to that vector we defined earlier. So since the z is 0, that makes its z coordinate be equal to its parent. And then that's it, really. There's nothing really particularly special about this. It wasn't all that hard to make. I made it in maybe half an hour. And the code snippets for the 3 scripts that I use will be available for download in the description, so you don't need to copy them down. I'm sorry to those who did already. But my goal with this little project was that you'd be able to take this project and then do something cool with it. Whether that be you make a really awesome astronomy game, or, you know, something else, I don't know.